All right, so section 2.3D part 2, right? So this is the second part of the types of lines that we're supposed to know. So parallel lines we did last time. Just a real quick recall here. We're supposed to know that parallel lines, these are lines that have the same slope, okay? So lines that have the same slope. So that's the important part for that, okay? Same slope. So that means if I look at one line and it has a slope of 5, then the other line, if it's supposed to be parallel, it's going to have a slope of 5 as well. Okay? So the slopes have to match. If they don't match, they're not parallel. Easy as that. Okay? Someone asked people, what about the numbers in the back? So let me just kind of show you what I'm talking about. They said like, what about if I had like a 2x plus 5 and y equals to 2x minus 3? Are these parallel? I said, yeah, they are because the slopes are 2 and 2. And they said, but what about the numbers 5 and minus 3? That just means that they're either higher or lower than the other line. That they're higher up or lower down, but they still have the same slope. So they can move up and down. It doesn't matter. Okay? But they're still going to be parallel. So the b value, the y-intercept, it does not have to match, or else they would have told us that, right? The only thing that has to match is the slope, okay? Now, well, I guess we are doing that today in a sense, because your homework is now going to say, are they parallel, perpendicular, or neither? So now they're going to give you some lines that may not be perpendicular, but they might be parallel, so you got to write that out, okay? But today we're going to talk about perpendicular lines. And these are lines whose slopes are opposite reciprocals of each other. Opposite reciprocals. In math, the word opposite means opposite sign. So the opposite of 3 is negative 3. The opposite of negative 5 is 5. Okay? So in math, the word opposite means the opposite sign. Okay? So, so every number has an opposite except for which one? Huh? 0. Because plus and minus doesn't matter for 0. It's neutral. Okay? But every number has an opposite. So 1 is negative 1, right? That's the opposite. Negative 8, the opposite is 8. All right? So that's not hard. So you're looking for the slope. That's opposite. So that means it has to be a different sign. All right? So if my slope is positive, the next one should be negative. If my slope is negative, the next one should be positive. Okay? Opposite. And then reciprocal. What does that mean to find a reciprocal of a number? You flip it. Okay? So I used to always tell people, instead of remembering opposite reciprocals, you guys know how like there's cars that have hydraulics and they jump up and down and they use switches and they flip the switches? So I tell them, flip it and switch it. That's what you do. Flip it, switch it. Okay? Switch the sign, flip the number. Okay? So if you want to remember opposite reciprocals, go ahead. That's the best way to do it because that's mathematically correct. The wording is mathematically correct. But you could also just remember for perpendicular lines, the slopes, you flip it and you switch it. Okay? So flip it and switch it. So in other words, let me give you an example of a set of perpendicular lines. So here's one. 3 have x minus 1 and negative 2/3 x, let's say plus 5. Notice how if I get 3 halves, which is the slope, if I flip it upside down and then I switch its sign, it becomes a negative 2/3. Okay? That is an example of perpendicular lines. Because the slope of one is 3 halves, the slope of the other is negative 3 halves. Oh, sorry, 2/3, not 3, but negative 2/3. So you got to flip the number around and switch it. So what if I gave you, let's say, a negative 3x plus 8? What would be the slope that I would need? Let me just put like the rest of it here. What kind of slope would I need to make it perpendicular? Positive what? 3. Not positive 3. Positive 1/3. Yeah. So you guys got me the opposite because you said positive 3. So you gave me the opposite, but you forgot to flip the number, right? Flip it and then switch the sign. So 3 becomes 1/3. Okay? And if you're thinking, where the heck did that 1 come from? Remember, every slope is a fraction, right? So you can write 3 over 1. Right? So you can flip it. Okay? So perpendicular lines, it's not that they're hard to do, but it requires more than parallel. Because parallel lines, you just got to say, this slope is 5, so this slope is 5. This slope is negative 3, this one's negative 3. If this one's half, this is, sorry. If this is half, this one's half. I said negative, sorry. I was changing the sign. But yeah, for parallel, they have to match, right? 5 and 5, negative 2, negative 2. They got to match. Perpendicular, you take the original slope, you're going to flip it upside down, you're going to switch its sign. And that's how you find the perpendicular slope, okay? So opposite reciprocal or flip and switch, whatever you want. So like I said, with hydraulics and stuff, you're flipping switches, right? So you flip and switch. So there you go. So let me show you a couple of things that we're going to have you guys do. So some examples. Example number 1. I'm going to put right here, are these parallel, perpendicular, or neither? So are these parallel, perpendicular, or neither? So let's start us off with this one right here. So I'm giving you 2 lines. I want to know if they're parallel, if they're perpendicular, or if they're neither. Now, you have to solve for y, right? Because you got to be able to identify your slope. So let's go ahead and identify our slope. So let me get both equations. I'm going to write them out side to side. That way I can work on them. And I recommend you guys do the same thing. Try not working on them like one on top of the other. Usually side by side is the best way to do it. And then we're going to start solving for y. Okay? So for the first one, let's get the 4x. We're going to move it over. That gives me 6y equals to negative 4x plus 8. And then I'm going to divide everything by 6 so I can get y by itself. So dividing everything by 6, that gives me y equals to, I'm going to reduce negative 2/3 x plus 4/3. Does the b value matter, the 4/3? No, right? If I'm just trying to quantify them as slopes, only the slope matters. So I don't care about the b. Now, let's do the other one. Let's get this 6x over here to the right side. Okay, so I get 4y is equal to negative 6x plus 12. All right, and then I'm going to divide everything by 4. Divide by 4, divide by 4, divide by 4. So I get y is equal to negative, let me reduce, that's 3 over 2x plus 3. Here are my slopes. Those are my slopes. Okay? Are they opposite of each other? No, they're not. Now, I know some of you guys saying yes. I know what you're thinking. They're flipped. But that's reciprocal. Opposite means the sign is different. So these are negative, both of them. So they can't be perpendicular. Are they identical slopes? No. So that means they're neither. Because if they were identical, they'd be parallel, but they're not. If they were opposite reciprocals of each other, then they would be perpendicular, but they're not. So for this one, you're going to write neither. Okay? Are we okay with this one? Why it's not parallel, right? They're not parallel because they're not equal. They're not perpendicular because yes, they are reciprocals of each other, but no, they're not opposite signs. How would I fix, let's say the second one, what would it have to be perpendicular, the second slope?
It would be no negative. Let's say positive.
It would be positive, right? Yeah, this would have to be positive, and then it would work. Okay? So then we'd have an opposite reciprocal answer. Okay? So, all right. I did tell you guys, by the way, just an FYI. I told you guys this before, but I don't know if you remember it. Probably not, because it's not something that I was asking you to do. But given x equal to a number and y equal to a number, these are always parallel or perpendicular. Think about their graphs. When you graph x equals to 2, how does it look? Is it vertical or yeah, it's vertical. If I graph y equals to something, what is it? Like this. These lines are not parallel. They're perpendicular. Okay? So these are always perpendicular. Okay? The reason why I tell you that is because there's going to be a problem like this. Okay? So the way you're going to check it is by remembering x and y's, they go like this. They always cross at 90 degrees. So there you go. So that's going to be perpendicular, okay? So I don't want to do a problem like that. It's going to be a waste of our time. But let me just give you the definition. Okay, so when they're x and y's, they are perpendicular. All right, another example like this, and then we'll move on. Because these are like the easy part of the homework, where they're just going to give you equations and oh, I'm sorry, not example 2. This is part B, right? Yeah, this is part B. Same instructions, just part B. So y equals 4 times x plus 2, and 4x minus 3y equals to 21. So hopefully one of these is perpendicular. I don't know. Maybe, maybe not. The next ones, they will be perpendicular. So because they're actually telling us they're going to be perpendicular. All right, so the first equation, I don't have to solve it. I already know the slope. It's 4/3. Okay? The first one, I already know the slope. The second one, let me go ahead and solve it. I'll move this over here. That gives me negative 3y equals to negative 4x plus 21. And then I'm going to divide everything by negative 3. So that gives me y equals to 4/3 x minus 7. So here's my other slope. Is this parallel, perpendicular, or neither? These are parallel, right? 4/3 and 4/3. If I wanted the other one, the one at the very end, to be perpendicular, it would be a what?
Negative.
Negative and, well, we did negative and flip it, so 3/4, right? So if the answer would have come out y equals to negative 3/4 x minus 7, then I'd say perpendicular. Okay? So remember, to do parallel, they got to match. So these are parallel. Let me go ahead and write that down. So if they're the same, they're parallel. If they're not the same, then you got to ask yourself, well, are they perpendicular? How do I check perpendicular? Well, they have to be the opposite sign. So if it's positive, the other one should be negative. If it's negative, the other one should be positive. It has to be the opposite sign, and it has to be flipped upside down. Okay, so a 3/5 becomes a 5/3. A 3/10 becomes a 10/3. Okay, a 1/2 becomes a 2/1. Okay, that's what we mean by flipping it over. That's the reciprocal part. The opposite is just the sign. So a plus becomes a minus becomes a plus. All right. So let me show you guys a couple of examples of the other types of problems they're going to give you, and that's it. It's only one side, your homework. It's 10 problems. They're all on one side. So hopefully I gave you enough room. I'm not sure. Depends on how big you write. But I think most of you guys would be okay. If you need to use a separate sheet of paper, feel free. But I think you'll be okay. So I'm going to write the slope-intercept form. So notice this is what we did yesterday on your quiz, right? Everything was always slope-intercept form, blah, 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 right? Of the equation. And right now I'm going to write down the equation. So we'll do 2 of these, and then I'll give you guys your homework. So it's going through 1, -5, and perpendicular. Now, you're going to notice in your homework, it's going to say perp. Okay? But it does mean perpendicular. So I'm just going to write it out. 2, y equals to 1, 6x plus 1. So you guys did this before, just that before it said parallel to. So with the parallel to one, we just used to take the slope and copy it, right? So my slope was 1/6, so that's what my other slope was. Now here, since it has to be perpendicular, what does my new slope have to be?
Negative.
A -6, yeah, -6. Because I gotta flip this upside down, and I gotta change its sign to a minus sign. Okay? So that's gonna be my slope, and then I have that point right here, 1, -5, okay? So I have a xy there. So I'm going to go ahead and use that formula, y equals mx plus b, and I'm going to put in my m, my x, and my y, so I get -5 is equal to -6 times 1 plus b, right? It's always the case that we got to find our b value. So -5 is equal to -6 plus b, and if I move this over, I get that b equals to 1. Because I'm adding 6 to the left side. So -5 plus 6, that's 1. Now that I have m and b, I can just write my answer. So my answer is going to be y equals -6x plus 1. I mean, hopefully by now you've done enough homework, you've seen it on the test. Anytime you have to write an equation of a line, the main things you need, slope and intercept. Okay? So if you find the slope, then you got to find the intercept. If you don't have the slope, find the slope. Usually they'll give you 2 points. You use the slope formula, you'll be able to find the slope. Okay? Every problem is identical. Maybe different starting point, but it's always find m, find b. Okay? So let's do one last one of these and then I'm done. I just want to show you guys 4 examples. That way you have stuff to kind of look back on. So let's try doing through this point here, 2, -2, and perpendicular, so I'm going to write perp this time, to y equal to 2/5 x plus 1. Again, this is the last one. So if this line has to be perpendicular, what does my new slope have to be? 5/2 and negative, yeah, -5/2. That's my perpendicular slope. Okay? And then again, I got to find b now because I know m. Let me find b. So here's my x and y. I'm going to put that into my equation, y equals to mx plus b. Okay? So I know y is -2, x is 2, m is -5/2. So -2 is equal to -5/2 times 2 plus b. those twos are gonna cancel out, right? The 5 over 2 times 2, these cancel. Okay, so that becomes negative 2 is equal to negative 5 plus b, and if I move the negative 5 over, what's b equal to? 3. So my answer, y equals negative 5 halves x plus 3. And these are perpendicular.